Hello, everyone. This is Dr. Bidemi, and today we'll be taking a look at the topic risk, uncertainty, and choice. Risk, uncertainty, and choice. All right, let's dive straight in. In the earlier chapters, we assumed a certain world, that is, one in which the consequences of any consumer choice were fully known before the choice was made. This is hardly the case in the real world. This section will introduce the idea of uncertainty and risk and examine their implications for consumer choice. Now, what is risk? Risk refers to situations where the probabilities of different outcomes are known or can be estimated. Decision makers can evaluate these probabilities to make informed choices. For example, in financial investments, the probability of achieving certain returns or encountering losses can often be estimated based on historical data, allowing investors to assess potential risk. So, one important particular characteristics of risk is that the probabilities of different outcomes are known. All right, in risk, the probabilities of different outcomes are known. What about in uncertain situations? Uncertainty refers to situations where the outcomes and their probabilities are unknown. So you don't know what will happen, okay? Making it difficult or impossible to predict future events with precision. So for risk, you are informed about what can happen. So you weigh your options. For certainties or for uncertain situation, you don't know. Okay, you don't know if this would happen or if this would happen. All right. Now, let's take a look at expected value in those certain situations. Expected value is a way to estimate the average outcome of choice or decision when the result is uncertain. Imagine you could repeat a choice or investment many times under the same conditions. The expected value tells you the average payoff you'd get over the long run. If there are two possible outcomes having payoff x1 and x2, with probabilities of each outcome P1 and P2 respectively, then the expected value will be P1 x1 plus P2 x2. So the P1 probability of the payoff on outcome 1 and P2 probability and outcome multiplied by payoff for outcome 2. Let's give an example. For example, if there is a 60% chance of earning $100 and 40% chance of earning $500, then what is the expected value of this event? That would be 0.6. Okay, this is it, right? Multiplied by 100, this is what you have here, plus 0.4, you have that here, multiplied by 500. Okay, sorry, yeah. Okay, so the expected value of this event would be $60 plus $200 equals $260. Let's give another example. Consider an investment scenario where two possible outcomes, okay, a profit of $5,000 with a probability of 0.6. So we know what our P1 is, P1, X1, and a loss of $1,000 is minus 1,000, it is X2, then P2. So 0.6 times 5,000 plus 0.4 times minus 1,000. So the, the expected value of this event will be 3,000 minus 4,000 equals to $600. Therefore, the expected value of this investment is $2,600, meaning that on average, the return is $2,600 per investment if this scenario is repeated over and over and over and over and over again. So in uncertain situations, the expected value, you can determine what the expected value will be on average if you repeat that situation. If that situation repeats itself under the same conditions over and over again. Okay? So let's take a look at preferences towards risk. In terms of preferences towards risk, we can take a look at it from three major angles. Okay, someone could be risk averse, someone could be risk neutral, and someone could be risk loving. All right, a risk averse person is someone who does not love to take risks. A risk neutral person is someone who is indifferent in taking risk, is indifferent about risk, or is indifferent about risk. Okay, about certain or uncertain outcomes is indifferent. A risk loving person is someone who loves to take risks. All right. So here it says a risk averse person who is someone who prefers certainty to uncertainty when it comes to decisions, especially if the uncertain choice involves potential loss. In other words, they would rather accept a lower but more predictable payoff than risk a higher but uncertain payoff. In simple terms, a risk averse person is someone who does not love taking risks. Where diminishing marginal utility exists, consumers are risk averse. So, for risk averse individuals, they exhibit diminishing marginal utility of income. Okay, they exhibit diminishing marginal utility of income. What about for risk neutral? For a risk neutral person, I also already mentioned that a risk neutral person is indifferent. Okay, it means that it has the same utility if it takes that action or it doesn't, or if it takes a decision or it doesn't take the decision. You can see it says a risk neutral person is indifferent between certain and uncertain outcomes with the same expected payoff. On average, the amount you would expect to gain from different choices is the same. Okay, risk neutrality implies constant marginal utility of income. All right, so you remember for risk averse, they exhibit diminishing marginal utility of income. For risk neutral, they exhibit constant marginal utility of income. What about someone who loves to take risk? A risk loving person is someone who loves risk. The preference for risk in which a person prefers risky income to guaranteed or certain income. A risk loving person prefers to undertake risk and is even willing to pay to do so. Okay, risk loving arises due to increasing marginal utility of income. All right, so once again, for risk averse, they don't love to take risk, they have diminishing or decreasing marginal utility of income. For risk neutral, they are indifferent towards the risk. What that means is that the utility they will get from taking the risk or not taking the risk, or taking the decision or not taking the decision, will be the same. So, and they exhibit constant marginal utility of income. For risk lovers, they love to take risks, they are willing to pay to take that risk, and they have increasing marginal utility of income. Increasing marginal utility of income. When we draw the graph, okay, we are going to get to the point when we do our calculations and we draw the graph, you would see the shapes of these risk preferences. So we have a question here. So let's solve this question. You are faced with two choices: to play a lottery and win $100 with a probability of 50% of winning and 50% chance of losing the $100. So 50% is 0.5 or 1 over 2. All right. So in this situation, the first situation, playing the lottery and winning $100, 50% of winning $100, or 50% chance of winning $100, or losing $100. In this risk, there's an uncertainty here. And where's your certainty? You don't know if you are going to win $100, or you don't know if you are going to lose $100. You are aware of the risk of playing the lottery, right? But you don't know what the outcome will be. You have an idea of, okay, let me play the lottery. I can or I might not. It's a risk, but you don't know what exactly is going to come out. Okay. So the first situation that you have is that you are taking the risk. But in this risk, there is uncertainty in this risk because you don't know what you would actually win. Okay. On the other hand, if you do not play the lottery, you will be given a guaranteed outcome. We've already done, I've given you situations where we did expected value in um, uncertain situations. Okay. So, on the other hand, if you don't play the lottery, you'll be given a guaranteed amount of $50. So, giving a guaranteed amount of $50 simply means you are not taking any risk at all. All right. The first one is you are taking a risk of playing the lottery. It's a risk on its own, but you are not sure if you are going to win or not. So the outcome is uncertain, but you have an idea of what the risk is. Okay, so for the second one, you are not taking a risk at all. You'll be given $50. All right, so we would like to know if you are risk averse, if you are risk neutral, or if you are risk loving. We'll have to calculate situations where you are risk averse, risk neutral, and risk loving. So for the first one, so for risk averse, this $50 right here is right here. So it's guaranteed $50 if you don't play the lottery. And this one right here, this one right here is 50% chance if you play the lottery you win $100. 50% chance if you pay the lottery you can also lose everything. Okay, 50% chance if you play you win $100, and 50% chance if you play you can lose everything. And the first one is $50. You're not playing. All right, we'll give you a guaranteed amount. All right, so of course you already know for risk averse, it will prefer $50 above this scenario here. Yeah, above this scenario here. So the utility of, we want to prove for risk averse, utility of $50 should be greater than utility of if he decides to play the lottery. Okay, so let's prove. You need this formula right here to be able, this one. Okay, utility of x, which is the event, equals to square root of x. So you have utility of the guaranteed amount. Utility of 50 equals the square root of 50. So you need this one here. So U50 equals square root of 50 is 7.07. So the utility of the expected value, if I'm giving you $50, what utility would you derive from it? This is 7.07. So let's scroll down right here. So now let's find out expected utility of the lottery. What is the expected utility of the lottery? Okay, we have this 0.5u into bracket $100. That equation that I wrote here. Yeah, this one. This one here. So let's scroll down. So you have expected utility equals of the lottery equals 0.5 utility $100. So expected utility 0.5 utility plus 0.5. There's something missing here. Here you should have, yeah. So here should be a square root, right? Because we need this. So I'm going to put it now here. The square root of 50. Okay, here should be, let me insert it right here. Where are the equations? Let me see. Let's find our equations. So here you're going to have square root of 100, right? So the other part, you're also going to have, not 100. Square root of 0. So that's how we derived. I'm going to take this out. I'm going to take this utility out. Take this out. So that's how we derive this 10 that you have here. So that is 0.5 multiplied by 10 plus 0.5 multiplied by 0. So the expected utility of playing the lottery will be 5. The expected utility of playing the lottery will be 5. So you see, I said you can observe that utility of the expected value, which is 7.07, is greater than the expected utility of playing the lottery, which is 5. This demonstrates risk averse. Let's take a look at our graph. Okay, so this is your for risk averse. This is the curve. This is how the curve is. Okay. Okay, this is how the curve is for risk averse, like this. All right, and so $100 if you play the lottery. Okay, you remember we did square root of 100. For square root of 100, you're going to have 10. That's how we got the 10. So the utility, this $100 square root of 100 is 10, right? For the $50, this is the guaranteed sum, this one. Okay, so we want to be able to show on the utility axis what you would have. So if you trace this up, all right, just draw if you how to draw it. Let me use pen. You have this. You have this. No, let me. Okay. You have this. Let me first draw the curve. This is the curve. Let me put the dotted line. Okay. Trace this down. Trace this up. So you have 100, which is the $100 if you play the lottery. You know we have the formula we used was square root of x. Okay, the square root of 50 and square root of 100. So here you have 100, you have 10. That's what you're going to have here. This is where you have the 10. For example, here, right here, square root of 100. You have the 10. Right. We also have right here. So for 50, if you play the for 50 right here, so playing the lottery, if you don't play the lottery for $50, we take this up to this curve, the risk averse curve, 7.07. You remember the answer? Our square root of 50, 7.07. You also trace this on the same line as 5. So you can see this expected value, utility of the expected value of not playing the lottery is greater than the utility that you would derive if you play the lottery. Okay, the utility that you derive that you play the lottery. This is straightforward. For example, this 100, this is the square root, 10. 50, this square root, that is 7.07. All right, you trace it down here also to be able to show if it's greater or less than the value you get when you play the lottery. So let's do that up. So one of the things you must remember in this formula is you must remember this equation right here. This one is so this one here is so important because that's what you also need that right here. Let's go to risk loving. For a risk lover, for example, what do you need? You need this equation here. So, of course, you know for a risk lover, he would prefer a situation, this one, better than this one. So taking the risk will be greater than the guaranteed sum of $50. Okay, I said you need this equation. Utility of x equals x squared. All right, so you put your 50 there, 50 squared equals 25. So utility of the expected value is 2,500. Okay, now let's look at the expected utility of playing the lottery. All right, remember you need this here. You always need that. So let's take that here. I hope is, I think that also is not there. So we have to put it. Okay, so for risk loving, you have, here is meant to be 100 squared. Okay, so let me put this in bracket. So you have utility of 100, right? So here you are meant to have, um, let me take this out, right? You should have, we need this formula x squared. So what we need to do is I can decide to put the u, okay, or I'm going to leave it like this 100. Let's look for our insert here. Where's our equation? Let's see, this will do 100. I hope it will do, yeah, 100 squared. Okay, so I'm going to, yeah, put this in bracket. I'm going to put this in bracket, right? Okay, I'm going to do the same thing for this place, but yeah, so but this one will be 0, right? So I take out this one. So I can decide to say, for example, utility here. I can decide to say utility here. All right. So, but let me take this out. Uh-oh. All right. So this is where we derived. So 100 squared is 10,000. All right. Okay. So we are using this formula that you have here. All right. So just put it here. This place right here. We need it right here. Okay. 0.0 squared is, of course, that's 0. Multiplied by 0.5, that will give you 0. So 0.5 times 10,000 is 5,000. And you could see here that you can observe that utility of the expected value is less than expected utility of the lottery. What that means is that expected utility of the lottery is greater than the utility of the expected value. This shows you this is a risk-loving person. Demonstrates risk-loving. Okay, and this is the graph. Okay, the same way you have 10,000. Yeah, it's correct. So you have, let me clear this. So you have $100, which is what you get if you play the lottery. You remember the formula that we used? X squared, right? So 100 x squared, that's 10,000. $50 if you don't play the lottery, right? $50, 50 squared, you have 2,500. Okay, so for playing the lottery, you will see if you trace this up, you're going to have, so this is greater than this. All right, so that shows you that is risk loving. Right, let's go to the last one, which is risk neutral. For a risk neutral person, is someone who does not love, who is indifferent. Sorry, who is indifferent about taking risk. A risk neutral person is indifferent about taking risk. Okay, the same way, of course, you know that already. You know that risk neutral. Okay, this utility of the expected value will be equal to the expected utility of playing the lottery. You have um, you will have the same value. All right. So utility of x, this is the formula we need right here. X over 10. X over 10. We need this. All right. So what do you do? Utility of the expected value. We know it is 50. 50 divided by 10. Utility of the expected value is 5. What about the other one? Expected utility of playing the lottery. The expected utility of playing the lottery. So if x over 10, that will be, this one will be into bracket. That would be x here is 100 divided by 10, right? Here would also be 0 divided by 10. Okay, so in this case, what happens? That's 0.5. 100 divided by 10 is 10. That's where we have 0.5 times 10. Here, 100 divided by 0 is 0. That's why we have 0.5 divided by 0. And so your expected utility equals to 5. The expected utility equals to 5. So you can observe that utility of the expected value equals the expected utility of playing the lottery, which is 5 equals to 5. And this demonstrates risk neutral, or someone who is risk neutral. Okay, so let's take a look at the graph. 100, okay, you have 10, 50, you have 5. So here you can see that utility of the expected value equals the utility of playing the lottery. So here 10, you know how we derive 10. It is x over 10. So 100 divided by 10, you have 10. All right. And here also you could see that 50, for example, divided by 10, you're going to have 5. And also we have 5 for the 2. Okay, 5 for if you don't play the lottery, and 5 for if you play the lottery. So you have some review questions. What is the difference between risk and uncertainty? For risk, you are you know what can happen. You are privy to what could happen if you take a decision. For certainty, you don't know what might happen, right? You are not, the probabilities of the outcomes are not clear. You don't know, for example, if someone tells you what will happen in 5 years' time, you don't know what will happen. All right. You might have a sense of saying, oh, maybe this or maybe that, but you can't guarantee that in 5 years' time, this is what is going to happen. In some cases, it's like that. Maybe you are doing a project, you are having a building. For example, nobody knew that COVID would happen. All right, that's how uncertain life is. But as uncertain that life is, there are also elements of certainty in life. If someone asks you in a year's time, what do you think might happen? You can say in a year's time, or 2 years' time, or in 3 years' time, oh, I should be done with my uh, master's, or I should be done with my bachelor's. All right, that's elements of certainty. But risk is if you're taking a decision, you know what will happen. You know the probabilities of the outcome. Or certainty is you don't know what might happen. You don't know uh, you are not privy to what can happen. Okay. All right. So explain and calculate the 3 types of risk preferences. Okay. What are the 3 types of risk preferences? You have risk neutral, you have risk loving, and you have risk averse. For a risk neutral person, or let me start from risk averse person. From a risk averse person, he doesn't love taking risk. All right. And so such a person's income, such a person exhibits diminishing marginal utility of income. Okay. For a risk neutral person, the person is indifferent between certain and uncertain outcomes. It doesn't, what that means is that the utility is going to get from taking the risk will also be the same utility or satisfaction is going to derive if he doesn't take the risk. Okay? And the person exhibits a constant marginal utility of income. For a risk-loving person is someone who loves to take risks. Okay, a risk-loving person loves to take risk. All right. And so he exhibits, such an individual exhibits increasing marginal utility of income. In fact, I mentioned that a risk-loving person wouldn't mind paying to take that risk because he knows that the income or the revenue or the amount he will get from taking that risk might be very large if he wins. That's someone who is risk-loving. All right. And I hope this is clear. Okay, so remember, this is the graph, this straight line. Okay, for risk neutral, this is the graph relating to risk neutral. This straight curve here, the line here. Okay, let me clear all. What about so for a risk? This is for risk loving. You see, risk loving kind of bow out. Okay, he bows out. All right, so this is the curve for risk loving right here. This one here. This is the curve for risk loving right here. And for a risk averse person, this is what it looks like. This is the curve. Let me clear this. This is the curve. All right. So I hope you find this quite informative. So if you have any question, feel free to send me a message or just put a comment on my YouTube channel. Then I'll be able to respond to you. Okay. I hope you find this quite interesting. All right. Until I see you in the next class, have a wonderful, 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 and a productive day. Bye and God bless.